and welcome to Yachting Monthly's how-to series, brought to you in association with GJW Direct. I'm Matthew Sheehan, and over the course of 13 episodes we're going to be dealing with some of the key issues when it comes to maintenance and talking to some of the experts to get their tips.
So every boat has a number of gauges on it for your fuel tanks, for your water tanks, it can even be for your waste tanks. And from time to time you're going to find that one of those gauges is not giving you the reading. It's either ceased to function completely or it's giving you a reading that's blatantly not correct. On our set of gauges here we can see that our forward fuel tank gauge is giving us a completely meaningless reading. It's off the top of the gauge for full, which is a sure sign the tank is not that full, that gauge has stopped working. Now that can seem like a complex or kind of mysterious problem to solve, but actually with a very little bit of knowledge you can pretty quickly diagnose what the problem is and quite possibly fix it. We only have the gauge itself, the wires from the gauge, and then what's called the sender in the tank, in this instance the fuel tank. One of those three things will be faulty, and what I'm going to do is show you how to find out which one it is. So before you do anything to your electrical system, I would always just recommend you switch it off. You can just switch off the circuit that relates to your gauges, but it's very easy just to drop a nut or a wire on one part of it and short everything out. So just switch off your electrical system first, which I'm going to do right now. And all the gauges are off. Now you'll usually have 4 wires going into your gauges, and these are really very simple, but just look at the instruction manual for your gauges. So on this one we have a positive DC feed in. This powers the gauge. We have a negative, the other side of the DC circuit, and there are 2 wires on this post because we daisy chain the gauges one to the other, so that's just joining the negatives together. So a positive, a negative, and finally a sender, and this is the wire that transmits the information from the sender in the tank to this gauge. And as we're going to see, all the sender circuit does is chop into the negative part of the circuit and increase or decrease resistance, and that will affect how much voltage goes into the needle and therefore affect how much that needle moves from empty to full. You will often find there's also another positive wire, which this gauge is missing, which is just the wire, the positive for the light in there to light up the gauge. R1 seems to have gone missing on this. So expect to see 4 different posts, positive, negative, power to the light, and the sender wire. And these will usually be marked. You can see the I for the positive. It actually says here GND for the ground, for the negative, and it has, if you can see it there, an S for the sender. It is very important you never touch a positive wire to the sender, or you will certainly break the sender in the tank and likely also break the gauge. So the first thing we want to do is check that the gauge itself is getting voltage, because if there's no voltage it's obviously not going to show you anything. So take your multimeter and switch it on to DC voltage, which is the V with the straight lines next to it. Your multimeter might be set up slightly differently, but just make sure it's on the voltage there. And then we're going to take our black and our red prongs, and it doesn't actually matter which way around you do this. Put 1 on the positive, 1 on the negative, and we're looking to see that we've got good voltage. This is a 12 volt system. We've got our battery charger on, and if I could just hold it steadily there, you'll see we've got around 13 volts, which is a normal voltage for a 12 volt system having lots of charge. So we know that this gauge has got voltage going to it. One of our problems is ruled out. Now it can only be the sender wire from the gauge to the tank or the sender in the tank itself. Here's our fuel tank, and here is a very standard type of sender. You'll see very quickly where the sender is. R1 happens to be our inspection hatch, but it could be anywhere on your tank. This wire here, don't worry about this, this is our bonding wire, which you'll have seen from our previous bonding videos. Now, from this sender you have two wires. They'll usually be different colour, blue and black. It doesn't actually matter which one is which. One will go to the sender post on the gauge, and the other one will go to the negative post or the ground post on the gauge. It doesn't matter which way is which. For this system, check the instructions on yours. Now let's see what a sender looks like. To do that, I'm going to pull these out of their connections like so, and then all we need to do is just unscrew our sender like so. Careful not to spill the diesel. And this is a very typical sender. This is the donut model, which in effect just puts a magnetic signal up the inside post. Your one might have a lever arm, but all this does is record the level of fuel in the sender. Now we need to make sure that this sender works properly, and as we've talked about, this is just about changing the resistance in the circuit. So we're going to get our multimeter, put it onto resistance mode, and then move this gauge up and down, and we'll see the resistance change if this sender works. With our multimeter now, we're going to move it to the resistance setting with the ohms, and we can lay that down somewhere near our gauge. We'll always just put our two probes together to check that it's working. Whoops. And now we're just going to put one gauge into each of our wires, like so. Now, as we move the donut up and down, we can see the resistance change in the multimeter. So we know this sender is working nicely. It doesn't matter what the resistance is, we can just see that as the fuel level moves, the resistance is changing from the sender. And all we've done is resistance setting on the multimeter and one probe onto each of the wires. Now we saw from looking at the sender in the tank that all we're doing is getting a different level of resistance in the circuit through to the gauge, and that affects where the needle shows from empty to full. By default, therefore, if we remove all the resistance, in effect ground out the sender, we'll quickly see if this gauge is working. To ground out the sender, we just take a test piece of wire, put one on the sender post and one on the negative post. And as we do that, we can very quickly see that the gauge is working. We've removed all the resistance by in effect touching the battery negative. This gauge has got power and it's working fine. So now we know the problem with this gauge, or with this fuel system, the recording system here, is either the wire to the sender in the tank or the sender itself. So we're going to put one end of our wire on the sender post, and being careful not to touch the positive, we're going to touch the other end to the ground post, to the negative post. And you should very quickly see the gauge flicking 100% from one side to the other. It doesn't matter which way it goes, each gauge is different. This is one of the wires that comes from the sender in the tank. and this is the other wire that's come from the sender in the tank. We've done a continuity check, there's no breaks in the wire. What we actually found with this gauge is that the sender wire wasn't firmly attached. The nut had come loose. So we're going to put that back on, put the washer on and the nut. We'll get that tightened up nicely. First finger tight, and then with a little spanner. Don't over tighten these, you're just tightening metal into plastic, and it's quite easy to over tighten and break in them. Like so. And now we can be absolutely sure, I'll tighten that in afterwards, that when we switch the power back on, the gauge is working. So you only have a very few things to check if a gauge isn't working. Check you have power to your gauge. Check the resistance in the sender, and check you have continuity in the wires between the sender and the gauge. One of those three things won't be working. The gauge won't be working, the sender won't be working, or there's a break in the wire. It can't be anything else.
Well, thanks for watching. I hope that was of help. Make sure that you like us, make sure that you subscribe to us, and stay in touch for the next episode.